Unlocking the power of statistics. Statistics is more than just numbers. It's a powerful tool for understanding the world around us. It allows us to make informed decisions based on data, predict future outcomes, and identify patterns that might otherwise go unnoticed. Let's start with the foundation, probability. Probability is the measure of how likely an event is to occur. It's expressed as a number between 0 and 1, where 0 means the event is impossible, and 1 means the event is certain. Think of flipping a coin. The probability of getting heads is roughly 0.5, or 50%. Understanding probability is crucial because it forms the basis for many statistical concepts. It helps us quantify uncertainty and make predictions in situations where the outcome isn't guaranteed. This is especially useful in fields like finance, medicine, and even sports. A distribution describes how data is spread out. It shows the possible values of a variable and how often each value occurs. One of the most common distributions is the normal distribution, often called the bell curve. The normal distribution is symmetrical, with most values clustered around the average. Many natural phenomena, like height and weight, tend to follow a normal distribution. Understanding distributions allows us to see patterns and make inferences about populations. Other important distributions include the binomial distribution, used for binary outcomes like success or failure, and the Poisson distribution, used for counting events over a period of time. Each distribution has unique properties and applications. Hypothesis testing is a method for determining whether there is enough evidence to support a claim about a population. It involves formulating a null hypothesis, which is a statement we want to disprove, and an alternative hypothesis, which is what we believe to be true. We collect data and calculate a test statistic, which measures how far our sample data deviates from the null hypothesis. We then calculate a p-value, which is the probability of observing our data if the null hypothesis were true. If the p-value is small enough, typically less than 0.05, we reject the null hypothesis and conclude that there is evidence to support the alternative hypothesis. Hypothesis testing is used extensively in scientific research to validate findings. The confidence interval provides a range of values within which we believe the true population parameter lies. It's an estimate of the uncertainty associated with our sample data. A 95% confidence interval, for example, means that if we were to repeat our experiment many times, 95% of the resulting intervals would contain the true population parameter. The width of the confidence interval depends on the sample size and the variability of the data. Larger sample sizes and lower variability lead to narrower, more precise intervals. Confidence intervals are a valuable tool for making informed decisions based on incomplete information. They are used in various fields, from polling to medical research, to provide a range of plausible values for a population parameter. This helps us understand the limitations of our data and avoid overstating our conclusions. Regression analysis is a statistical technique used to model the relationship between two or more variables. It allows us to predict the value of a dependent variable based on the values of one or more independent variables. Linear regression, the simplest form, assumes a linear relationship between the variables. The goal of regression analysis is to find the best fitting line or curve that describes the relationship between the variables. This line can then be used to make predictions about future values of the dependent variable. Regression analysis is widely used in economics, finance, and marketing. It helps us understand how changes in one variable affect another, allowing us to make informed decisions and predictions. For example, we can use regression analysis to predict sales based on advertising spending, or to estimate the impact of interest rates on economic